Hello class, we're going to be looking and starting this year just by looking at what is a computer. Before we get into programming, kind of want to have at least some kind of basic idea of what a computer is at all. So we're going to start with that question, what is a computer? And even this word computer over time has really changed. I used to, or I would typically show a little video clip here, so you could take a look at this YouTube later on. Um, and if you watch this YouTube, it's quite interesting that they use the term computer in terms of referring to a person. A computer used to be a person who would compute, a person who would do math operations really fast. And so you'd have a room full of computers. It would actually be a room full of people that are doing lots and lots of math problems. That's what a computer used to be. And these computers, these people were used to make the calculations necessary to send, the first man to the moon. And this movie, Hidden Figures, it's a really great movie. You should watch this movie. But it's about three black women who actually were really instrumental figures in doing all these calculations that would eventually help us get to the moon. And yeah, so go watch it. It's a great movie. It has computers, it has math, it has just the whole history and kind of the social issues of the time. Yeah, one of my favorite movies. Anyways, today when we talk about computers, computers are actually the machine itself, not people anymore. So let's kind of take a little stroll through history. There's always been a need to count. People need to count how many, cows they have, how many sheep they have. They need to calculate. They have always needed to calculate how much taxes you owe, maybe how much money you owe the bank, or how much the bank wants to collect from you because they gave you a loan. And so there's always been a need to count or to calculate. And in the old times, the abacus here was a counting device, a calculator. It could do math, it could do addition, arithmetic. And we had this slide rule over here, which was really a tool that was used by engineers even as late as the 1950s, 60s, 70s. Before the handheld calculator came into existence. This was actually the device of choice that any sort of engineer would use. People invented things to do calculations for them, and back in the 1600s, a person called Pascal created what's called the Pascaline. It was an adding machine. It was a fixed function adding machine. Later on in the 1800s, a man called Charles Babbage, he created this big machine. It's actually maybe, say 4 feet by 4 feet by 5, 6 feet tall. So it's big, it was heavy. But what it could do was it could calculate the outputs of polynomial functions. It had some addition, it could multiply and things like that. And you would use a gear to kind of crank it to do your calculations. Then, we kind of advanced, and people then invented electrical mechanical machines, which were still based on Charles Babbage's invention previously, but now we have an electronic motor kind of turning the gears. And this is a big machine. It's actually something you could still see in Harvard today if you went to visit there. It's huge. It fits an entire room. It was 10,000 pounds. It was programmable. You could actually program it by putting your instructions on pieces of paper, and it could do one division every 11 seconds, which was pretty good, considering that it'll probably take you a good minute or more to do some long division, right? Okay, so those were the mechanical, electromechanical kind of computers. So now we're going to get into the modern computers, which are all electrical machines. And we're going to walk through 4 different generations of electrical machines, electronic machines. The first one was created in the 1940s based upon the invention of a vacuum tube. And a vacuum tube looks like this over here, and think of it as a light bulb. It's about the size of a light bulb, and it generates light and heat. But really what it was a switching device. And based upon this device, they were able to create what was called the ENIAC, which was made out of 20,000 vacuum tubes, and it weighed 30 tons. It consumed 150,000 watts of power. So just in context, your hair dryer takes about 1,000 watts. Your phone, your iPhone or whatnot, probably 5 to 10 watts. Your laptop, maybe 50 to 100 watts of power. And this thing consumed 150,000 watts, more than many households all together. This thing was programmed with wires, so you could see all these wires over here, and you see these people plugging in wires just as a way of reprogramming the computer to make it do something different. And this was an advancement. We can now do 35 divisions every second. So that was in the 1940s. So connect, first generation, vacuum tube. Second generation was based upon the invention of the transistor. Now the transistor was a device that functioned in the same way as a vacuum tube. It was basically just an electrical switch. So it's just like a light switch. You could turn it on and off. You know, a light switch is a mechanical device that with my hand I could turn the switch on or I could turn the switch off. A transistor is different in the sense that the control is not mechanical to turn it on and off, but instead there's an input, electrical input that you can provide that will turn it on or off instead. And so this transistor was pretty small, actually, you know, maybe 1/8 of an inch by 1/8 of an inch by 1/8 of an inch, or a few millimeters by a few millimeters by a few millimeters. So it's a very small device. So all of a sudden this vacuum tube, which is the size of a light bulb, is now shrunk down to this tiny thing. And it's smaller, it's faster, it's lower power. This box here is a mainframe computer made by IBM, made out of these transistors. And now it ran very fast. It ran at a speed of 1 megahertz, which is 1 million cycles per second. So think of that in terms of, instead of being able to do 1 division or 35 divisions every second, now it could do 1 million additions every single second. And I don't know how fast divisions were. Maybe it can do, I don't know, 50,000 or somewhere in that order every second, but basically 1 million additions every cycle. Division's a little harder. Okay, third generation of modern computers, 1960s now. So basically this idea of the transistor, all computers going henceforth are all made up out of transistors, but the invention was what this device called the integrated circuit. So now this integrated circuit, this picture over here, it's a device that's about 1 inch long and 1/4 inch wide, and inside of it are 10, 50, 100 different transistors inside of it. So this integrated circuit was able to hold many transistors inside. So again, basically what was going on was we were shrinking down the transistor into a smaller size so that we can do more stuff within less area. And so down below here is a mini computer based upon integrated circuits. It was a 12-bit mini computer running at 1 megahertz, and it was now kind of affordable for businesses. $20,000, not too bad. I mean, but you couldn't have this in your home. It's still way too expensive for that. I remember when I was in college, I actually programmed a device just like this. They actually had us, just to kind of get our own hands on it, to experience it, we had to flip these switches down on the bottom, and push some button over here somewhere as a way of getting information into the computer, flipping some switches, pressing a button, storing the next instruction. Okay, leads us to now the fourth generation of modern computers, which is based on microprocessors, which is basically putting millions of transistors onto a single chip, a single integrated device. So it is still the concept of an integrated circuit, but now we're talking thousands, millions, today billions of transistors inside of an integrated device. And the brain of a computer is the microprocessor. And it was a big step forward when we could put the entire brain of the computer, the microprocessor, into a single chip. And once that was done, this guy named Steve Jobs and Steve Wozniak invented or put together this little hobby device called the Apple I, and they would sell it for $666. It was an 8-bit processor. It ran at 1 megahertz. So it wasn't that it was necessarily faster than the previous one that I showed on the previous page, but now that entire processor sits inside this little tiny chip right here instead of that huge box. And it was now much more affordable, $600. We could actually afford this, you know, you and me. This could be a device that you can buy for your home. And so this was really the dawn of the personal computer. The Apple I, actually they went into market with the Apple II, and the Apple II was the product that I got, my dad got me when I was a kid. And that's what kind of made me fall in love with computer science. And so this Apple computer was kind of the really turning point in the whole computer kind of revolution of things. It brought the computer to the household. And nowadays we have, like, the machine I'm working on right now is a MacBook Pro. It has a 4-core processor, or 4-core chip. Instead of just a single processor, we have 4 processors inside. Instead of an 8-bit processor, now we have 64-bit processors. And so think of it as a 64-bit adder, and we're moving around data that's a lot larger. Running at 3 gigahertz, which is 3 billion cycles per second. Previously in the Apple I, it was running at 1 megahertz, 1 million cycles per second. So again, think of it as I could do a million additions every cycle, or a million instructions every cycle. And roughly now we can run 3 billion instructions every cycle. And then we have 4 processors, so we can run 12 billion instructions every cycle. And there's also memory. The original computer, Apple computer, had up to 48 kilobytes of memory. That's 48,000 bytes of memory. Nowadays, computers have 16 gigabytes of memory. That's 16 billion bytes of memory. So huge, huge, huge increase. And today computers are everywhere. They're not just in desktop computers, but there are computers in your phone, there's computers in your cars, toys that you buy your kids, all over the place. And here you see a picture of a chip, a computing device, a microprocessor. Look how small it is. It's smaller than a penny. So let me define this word computer. This is the way we'll define it in this class. It's a machine that processes some sort of input into some sort of output according to some programmable set of instructions. So the inputs here could be your keyboard that you're typing on, the mouse that you're moving, a microphone I'm talking into, camera, GPS, touchscreen. The outputs might be the screen that I'm looking at, speakers to hear, radio signals. Your phone is actually receiving radio signals on the input, sending out radio signals on the output as a way of kind of communicating with the cell tower. Your phone vibrates. So this is the idea of a computer, and in the middle of it is a central processing unit that is the brain. It's the microprocessor that is doing all of these instructions that you're telling it to do. And the fundamental instruction that you're telling it to do is to add or subtract, multiply, divide some numbers. So on the input, numbers are coming in. The central processor is doing math operations, and on the output, numbers are coming out. So as I just mentioned here, all the data that is coming in, coming out, even the instructions themselves, they are all numbers. And more so, in a computer, all the numbers are in binary. They're zeros and one. And we'll talk about why, kind of in the next lessons, why binary for computers. But for now, just understand that all data, whether it's input data, whether it's output data, whether it's the program itself, they're all just numbers. And so the way we've organized computers today is that we put all of this data, input, output, program, into one location called main memory. And that main memory then is connected up to the brain of the computer, the central processing unit. And so the processing unit is talking to the main memory, it's getting data from main memory, it's doing some math operation, and then it's writing that data back out to main memory. And again, the CPU, this microprocessor, is doing things according to some program in main memory. So you can imagine that it's reading the program from main memory in order to figure out what to actually do. So one more piece to kind of fill out the full picture of a computer. We have the brain in the middle. We have main memory. So for example, this is our 16 or 4 gigahertz computer microprocessor. Then we have our 16 gigabytes of main memory that holds all the input, output, program data. But we need to have some sort of mechanism to interact with it physically. So we have an I/O system also in a computer, which takes your keyboard presses, the sound of your voice, through a microphone, and it goes through some circuitry to turn it into numbers. And those numbers then get put into main memory. And then the reverse way is the same. Once the central processing unit has generated the output data, that output data then goes into the I/O system, to the output devices. So it then goes to the monitor as pixels on a screen, or these numbers go to the speaker, and the device translates that to sound that you hear out on your speaker. Okay, so this is the overall picture of a computer. So we'll continue on next time, talking more about binary and why binary, and a little bit about logic gates. Okay? Bye, everybody.